Hello and good morning. I am suggesting an experiment for anybody out there for a school science project or a college project or just a simple experimental project at your own home for fun. I'm suggesting that you experiment with a model of global warming. Like, I'll give you for an example. I mean, I haven't gone into detail about this, but I'm trying to encourage other people to find out whether the facts are the facts or we're being deceived in this global warming thing. What I suggest is like getting like a tub of water, or even if you have your own pond or something, use that as an example. And what you do is the global temperature is around 58 to 60 degrees Fahrenheit on average, so globally, the whole globe. Okay, now what I'm suggesting is, now if you got heat lamps or whatever, put the heat lamps at a projected temperature like 58 degrees, like the average global temperature, and then what I want you to do is slowly increase the lamp so that it's close enough to the water, or your project where you have ice, maybe use ice as glaciers or something like that, and sand and all. You just make like a model of the earth, a small model of the ocean or some land somehow, and then bring that heat lamp just a little bit closer so that it adds up to 1 degree, and tell me what the effects are. Tell me what the effects are on that experiment that you had, that body of land mass that you're going to make, and the ice and stuff, and tell me how fast the melting ratio is. I mean, you can make a working model, okay? Everybody says, well, the planet's too big to really calculate, all this. But now, if you make a small working model and you simulate things in a much smaller way, and you keep that constant temperature, and then you raise it up just slightly, tell me what the actual effects would be when you do this experiment. Now, I mean, there's other experiments you can do to see whether global warming is real and in effect. I mean, this is just one suggestion. I mean, if you come up with other ideas or suggestions to experiment with to see what's happening. For instance, if you can get some type of water that has some bacteria or plankton in it, living substance like plankton, what you take that and put a heat lamp over that. Like, say, this probably be an easier experiment. If you can get some water that has plankton in it, okay, from the ocean, and what you do is you take this heat lamp. Okay, we know that the average temperature is around 58 degrees. Now, slowly put that heat lamp a little bit closer. Now, you got to understand, you got to look at the ocean temperature in certain areas. So, say that the average temperature is 58 degrees. Just say the average tropical temperature is 76 degrees. Imagine if that went up by maybe 3 or 4 degrees, because 1 degree will affect other places going up like 10 degrees. So put the heat lamp just a little bit closer. Now, if you put something in the water that causes the plankton to die, like chlorine or something, that causes plankton to die, tell me what the effects are of the water temperature. Tell me if that water temperature will go up. I mean, they already know that the plankton in the ocean absorbs CO2, and it also absorbs the heat, so that the ocean doesn't get overheated. Well, when that is no longer there, what do you think the result will be if that plankton is not there? The result will be the water will heat up. But I'm not telling you to take my word for it. I'm telling you to take and do an experiment. A small scale experiment. I don't understand why these scientists are not doing this, and if they are doing it, to what degree they're doing it. I mean, obviously, common sense will tell you that the Earth will warm up. It's just like an egg on a stove. You put an egg in a pan. Say you put the temperature at a low temperature, right? Okay, it's still heat. You put an egg in there. Okay. The egg won't all at once cook up, but eventually it will. Eventually it will have an effect on that egg. It actually could have the egg to be fully cooked, so its original state is altered. Okay, even at a very low heat, that egg will cook. The same, you can use the same principle on things around you. Now, gradual effects in anything over time will have an effect. Now you got to understand that things accelerate with time too. So you got to look at those factors too. You know, heat on the Earth itself is a catalyst, and it will change the makeup of things. It will change the outcome of things. We've already had heat waves in Europe. We've had heat waves in my area of the world too, in the United States. But you got to understand this thing. When people say that everything is beautiful and everything is okay, and they're making these drawn-out speeches about our globe is wonderful, we're sustaining it and all that stuff, that's not necessarily true. There won't be no question about the fact of global warming if it was true. If our globe was in a good state and it was functioning as it should, there wouldn't be no debate on global warming whatsoever. Do you see what I'm saying? Since there is a debate on it, there is something going on. And, you know, to hear all these other scientists say that, oh, that's not happening, they're apparently not looking at all the factors, or they're just straight out not telling you the truth. Now, I don't have nothing against scientists in general. Not at all. In fact, I kind of revere them. I like them. Because they learn stuff and they cause, you know, new developments. But if they're withholding information, or they're just plain out neglecting information, then to me they're not a revered scientist. The scientists that I revere are those people that actually look at things as they are and look at the outcome and change. Everything in this life changes to a certain degree. Everything. There's a change. And scientists examine these changes all the time. That's their main focus. They go out in the ocean, they look at changes. They look at the effects of things. They're looking for change. Science is based on change. Okay? If it wasn't, there wouldn't be no purpose in looking into things. If things remained the same all the time, there would be no purpose in studying it. No purpose in looking into it. Because if nothing changed and there was nothing else to look for, these scientists wouldn't be in business. They wouldn't have nothing to research. This is common sense. And I hope anybody out there, or any scientist or teacher or educator or anybody that really gives a crap about what's going on around them will realize that things change and we are affecting change. I always use this word. I'm constantly trying to get this word out for people. Because in science, nothing stays constant, okay? Nothing. Over time, little by little, there are changes, okay? Nothing stays completely constant. Even the speed of light does not stay 100% constant. They say it does, but it fluctuates. I'm sorry, I know that it has to fluctuate. Common sense tells me that it does fluctuate in some ways, because something affects it from doing what it's supposed to do. So this causes change, whether minute or not. Now, I want to keep going on with this whole idea. I got a little sidetracked here, but catalysts. A catalyst is something that changes the physical outcome or physical change of something, a chemical change in something. It has an effect on physical things, okay? So catalyst will change something, the outcome of something. And now, not only that, when you affect things with a catalyst, when you cause things to change, certain things accelerate and some things decrease. So you got to look at the fact that global warming has an effect because something is increasing it. Something is causing it, whether small or great. When they say that global warming doesn't exist, it has to exist because they're already saying there's certain temperatures in the air of the Earth that are warming up. And contrary to trends, in the last 25,000 years, the temperature has only risen 36 degrees. And people say, well, how do you know this? Well, it's just a projection, actually, okay? But it's a very scientifically and mathematically based analysis, okay? So if in the last 25,000 years the temperature has only risen 36 degrees, okay? In the last 100 years it has risen 100 degrees. And they're going to say, oh, what about that cold spell they had back there, that little cold age they had in 1940 and whatever, around that small area? Well, you got to remember there are things that cause that. And you'll find this pretty freaking amazing because they don't probably talk about this too much. In Russia, and it was in the early 1900s, this meteorite or large object hit the Earth's atmosphere in Russia. Okay, I don't know if I'm telling it in full detail, but this object hit Russia at a great force and great speed, and it devastated a whole forest and caused a large amount of trees to be knocked over for, and there was a sound wave created by this, or a wave created by this, that was felt over 10,000 miles away. So you don't hear too much about this, and this is factual. You can look this up. You can look this up, I'm telling you. So that had an effect, and there was a lot of debris that was put in the atmosphere. And not only that, over that period of time, they didn't have all the technology and stuff in all the areas of the world to tell you about volcano activity. And volcano activity had affected weather too, as far as the cooling effect. So during that time, between the early 1900s, between 1920 and 1940, and even between 1940 and 1970, there was a slight cooling effect. Okay, but that was because there was something that caused change. That was a global event. That was global climate being affected by change. Okay, that's one instance. But what we're talking about now, from 1970 on, okay, about the heat index just going up 1 degree. Actually, it went up 1 degree, but I actually went up more than 1 degree, because in that 100-year span, we're not even calculating that cold spell. Okay, we're looking. Well, I'll just go on here. Maybe I'm a little confused on that, but I don't want to be. But the thing is, doing these experiments on a small scale will give you some idea, some degree of what effect is actually happening. Okay, because you're using heat, and you're using physical items that are already found in the earth. Okay, and heat energy is similar to the radiant energy from the sun. We're using a heat lamp, of course, but the sun is a direct energy that does affect the earth. Okay, and well, they talk about solar flares and solar activity. Yeah, that plays a role. Okay, but that's been playing a role in the last 25,000 years, so that hasn't really made a significant change in the overall global temperature. We're talking about in the last 100 years having a significant effect on global temperature. It's went up 1 degree, and they still say that it's rising. Now, not only that, if we're just talking about, that's just the surface temperature now. Okay. Now you can take into consideration the ocean being warmed up because of certain factors, the plankton dying, the earth warming up as well, and underground vents and stuff like that from volcanic activity maybe more active, causing the ocean to become more heated because of earthquakes and things like that. You got to look at all the things that are playing into this role, and then on top of that, you got that water temperature, surface temperature, and atmospheric temperature. Now, if all those are rising, will be a conglomeration or collection of energy and heat. Not only heat, you don't only have the heat in the atmosphere, you not only have the heat on the surface, you not only have then you have the heat below the surface in the ocean, and then even below that in the magma cores in the earth affecting. Now, if all these things are happening at the same time, you tell me what kind of effect it will have. You can do these experiments at home. You can take a big bunch of sand and put a small heat lamp underneath the surface of the sand in a box or something like that, as long as you don't burn it up. Use something that you're not going to cause a fire with, and you heat up that sand. Okay, and that'll be the earth, and that'll be below the earth heating up. Okay, that's an example. That sand will heat up. Okay, or you can use dirt, whatever you want to use. You want to make it real to life, use dirt. And then, okay, on top of that dirt or sand, put like a body of water, so the water doesn't seep down into the sand. Well, it could if you want to do, really make a multi-experiment out of it. And then you got on top of the sand, you have the water, and on top of the water you can put like a little ground area of some sort, and warm that up from a heat lamp onto the surface of the ground that you created or made in your experiment. And you're going to find out, if you heat up all those aspects, the core, the ocean temperature, the land temperature, and the atmosphere around it, there is going to be heating, significant heating. So it is not just one factor that's causing global warming. Experiment on this, and I'm telling you, when these scientists are talking, they're not putting all the factors into play. And the word catalyst and acceleration are very important. There is some deceleration in things, but those two factors, catalyst and acceleration, are very, very vital in understanding what's going on with our globe. And once things accelerate, it's hard to decelerate them. Okay? Just something to think about.